if V is the middle point of RU, then that means that RV is 1/2 and VU is 1/2. Well, can you tell me about half and half? Isn't half congruent to half? Okay, so I can set up an equation knowing this to solve for x. Now let's think about solving for y. That's the second bullet. It says that perpendicular bisectors must be perpendicular to the side. Okay, so if SV is a true perpendicular bisector, which is what it says, then SV is perpendicular to RU. Well, what does perpendicular mean again? It means it creates 90-degree angles. So that tells me that SVR is 90 degrees and SVU is 90 degrees. So wait, I know that this angle, it says that it's 3y, but I also know this angle is 90 degrees because it's a perpendicular bisector right here. So there's my other equation to solve for y. Number 2. It says, what do you know about DW and FW? So we need to check this additional information over here. It says any point on the perpendicular bisector, in this case, that's point W, any point is equidistant from the endpoints of the segment. So the segment that we're talking about in this case is DF. Remember, equidistant. That means equal distance. Okay? So W is equal distance away from D as it is from F. So what do we know about DW and FW? We know that they are congruent. So then you should be able to find for X here. Okay? Moving on. Angle bisector. Angle bisector is a line, segment, or ray that, what does a bisector do? It cuts or divides an angle into two congruent angles. All right? So again, we're going to make some notes out to the side. First note we need to make is that this has to pass through the vertex. Okay? Where are angles created? They're created at the vertex. Two sides meet, they create a vertex, bada bing, bada boom. There's my angle. Okay? So does it make sense that an angle bisector has to pass through the vertex where the angle is created? I think so. Okay? The other bullet that we need to write down is that it does not have to pass through the midpoint or be perpendicular. So it doesn't have to follow either of the things that the perpendicular bisector does. All right? So let's look at this. It says that AJ is the angle bisector of angle A. Okay? So this AJ here passes through the vertex. We can see that there. Okay? It does not have to be perpendicular, and it does not have to pass through a midpoint. So this J here, it could be a midpoint, but it doesn't have to be. Okay? We don't know anything about it other than it's some point that is labeled as our intersection between our bisector and this segment over here, BC. Okay? But what we do know is that once this AJ angle bisector happens, then angle CAJ, this small angle over here, and angle BAJ, this small angle over here, these two small angles are congruent. Okay? Well, just like when we talked about on our perpendicular bisectors, there are also 3 angle bisectors in a triangle because we have 3 angles, okay? Where all 3 of your angle bisectors intersect, that is called the incenter. That's another thing you need to know. It's called the incenter, okay? A helpful way to think about it is that the incenter is when the circle is inside the triangle, okay? So an incenter is the center of the circle that is inside the triangle. All right, so number 4, it says find the measure of angle W. So I'm going to go ahead and mark that, and I'm going to put a question mark there. If VY is an angle bisector, so VY is an angle bisector, okay? So if it's an angle bisector, it's obviously not bisecting WZ, all right? It's bisecting this angle Y up here. So if it's bisecting it, I know that these 2 smaller angles have to be congruent because that's what it says up here. It says we have 2 congruent smaller angles, okay? Well, if you cover up this left triangle, I can see over here that I know 2 angles, and I can find that one up there by setting 110 plus 40 plus angle VYZ, and that should all equal 180. Okay, so I can solve for that angle. All right, once I get this angle, I know that it's congruent to this one, right? So I can add these 2 together, this one equals this one, to get this large angle Y. After you get your large angle Y, you should notice that you have a large triangle. You should have been able to solve for Y. You know angle Z is 40. So you have that angle Y, the large angle is what I'm talking about when I'm talking about angle Y. We could say that is angle WYZ, that would be more correct, plus 40. Whatever this is, you should be able to solve for that, plus question mark, which is what we're calling angle W, should all equal, again, 180. Okay, so I'm setting that one up for you. Number 5 says find x if the measure of BAG is 5x minus 6, and the measure of CAG is 3x plus 12. Okay, you know those 2 angles are congruent. I shouldn't have to set that up for you. Should be solved. Okay, number 6, it says find x if KP is equal to 2x. So it says KP here is 2x and KQ is 18. Okay, again, it gives you the marks. Shouldn't have to set that up for you. All right, good luck. And again, if you need more help, please look at the video that is connected to this one. And remember, you have your gallery walk, and that will be due at the end of the period. All right, good luck. See you tomorrow. Hi guys. So for those of you who were absent or testing yesterday, I'm going to go ahead and I'm going to go through the notes that we went over yesterday, as well as going a little bit more in depth into the examples for those of you who were here yesterday that still may have not gotten what we needed to get out of it. If this video doesn't help you, please check the next video that will be linked with this one. All right, so perpendicular bisector is a line, segment, or ray that passes through the, well, if it's a bisector, it has to pass through the middle, so it passes through the midpoint of it has to be a side, because triangles have angles and they have sides. So there is no such thing as a midpoint of an angle, so it has to be the midpoint of a side. And is, well, it says here that it's perpendicular. You can write perpendicular, or you can do the perpendicular symbol, which is an upside down capital T. Okay? So I know we just filled in those blanks there, But over here on the side margin, we need to write a few things that are very, very important about perpendicular bisectors. The first one is that a perpendicular bisector has to pass through, and yes, I understand, I'm abbreviating through, it has to pass through the midpoint. Again, if it's a bisector, it has to go through the middle, has to go through the midpoint, okay? It also must be perpendicular to the side that it passes through. Obviously, it says perpendicular, it has to be perpendicular, okay? Lastly, it does not have to pass through a vertex. Okay, so let's look at this as an example. We see here that this perpendicular bisector right here, we can label this, say, E. Okay, so ED is our perpendicular bisector. If it is a true perpendicular bisector, it has to pass through a midpoint. Well, D here, it says, is a midpoint, and the perpendicular bisector passes through that. So that part's right. Okay, the next thing says it must be perpendicular to the side. Well, how do we know that two lines are perpendicular? Perpendicular lines create 90-degree angles. If you didn't know that, you might want to check in your notes. Okay, perpendicular lines will always create 90-degree angles. We have 90-degree angles right here. If we have one here, it is understood that we have one here as well. So it is perpendicular to our segment AC. It says it does not have to pass through the vertex. It can, but it doesn't have to. Reminder, a vertex is where two sides meet at a point. A is a vertex. Okay? So if you look here, it says that this triangle, it gives us 3 perpendicular bisectors. Okay, we have 3 sides, which means we have 3 midpoints. We've got H, we've got J, we've got G. Through those 3 midpoints, you can create a perpendicular bisector. So we have 3 perpendicular bisectors for this triangle. Where they meet is called the circumcenter. All right, that's important for you to know. I won't make you memorize a whole bunch this year, but this is one thing that you do need to make a connection with, that a perpendicular bisector creates circumcenter. Okay, the 3 perpendicular bisectors create the circumcenter. Okay, the circumcenter is in the center of a circle that intersects all vertices of the triangle. So the circle outside intersects all 3 vertices, and the circumcenter here is the center of that circle. All right, so number 1, it says find x and y if SV is a perpendicular bisector. So we know that SV is a perpendicular bisector. If it's a perpendicular bisector, we know these 3 things. All right, so if it's a perpendicular bisector, it has to pass through the midpoint. So what's going to be the midpoint? Does it look like it's going to be S? Probably not. Okay, V is our midpoint. Okay,